Welcome to this special edition of Genius Dialogues. Today, we have two of the most brilliant minds in the history of science, Sir Isaac Newton, the father of classical mechanics, and Albert Einstein, the revolutionary force behind relativity. Let's hear what they have to say about the universe, time, and gravity.
Well, Dr. Einstein, I must start by saying that time is a constant. It's one of the cornerstones of my laws of motion. Time doesn't change. No, it's steady, ticking forward at the same pace, always reliable.
Oh, Newton, I must respectfully disagree. Time is not constant, at least not as you see it. You see, time can stretch and compress. It's relative to the speed you're moving and the gravity you're in. It bends with the fabric of space-time.
Relative, you say? You're telling me time doesn't just tick on as it always has? How absurd. The apple falls to the ground at the same speed, regardless of where you are in the universe. That's a law of nature.
Ah, yes, the apple. But what if I told you that the apple would fall differently depending on how fast you're moving? In space, near a black hole, the apple might take a lot longer to reach the ground, just due to the warping of time. It's not just about gravity pulling objects. Gravity bends time itself.
I've never been one for bending time, Dr. Einstein. But gravity, yes, I know gravity well. It's universal, an attractive force. It pulls things down, straight to the ground, consistently. Your idea of time bending is almost like a science fiction story.
Well, Sir Isaac, your laws work brilliantly for objects at low speeds. But when things move close to the speed of light, everything changes. Time itself slows down. I've actually proved it mathematically.
Speed of light? Are we talking about a light beam now? I thought we were discussing apples, not beams of light racing across the universe.
Well, apples are nice, but when you're speeding along at near light speed, everything changes, even the passage of time. You might see an apple fall in 1 second. But if I was moving fast enough, it could look like the apple was suspended in time.
Suspended in time? Intriguing. But surely you don't think that gravity can bend space itself, do you? Space is vast. It's constant, unchanging.
Exactly. But that's the beauty of my theory. Space isn't just a void. It's a fabric that can be warped, stretched, and bent by mass and energy. The Earth, the Sun, they bend space, creating what we feel as gravity. No longer do we think of gravity as a simple force. It's the curvature of space-time itself.
So, you're saying that when I dropped my apple, it wasn't just the Earth pulling it down, but the space around the apple bending? How far do you think I could stretch this bending of space idea? Can I bend time to get more hours in my day?
Unfortunately, Sir Isaac, I can't promise you extra hours in your day. But what I can say is that in certain extreme environments, near black holes, for example, time slows down so much that an hour there could be years for someone far away.
I see, so while I'm stuck here with my absolute time, you're out there bending it like a magician. Well, Dr. Einstein, you've certainly made me reconsider a few things about the universe. But I must say, I'm still fond of my laws, even if you've bent a few of them.
You laid the groundwork for everything I did, Sir Isaac. Without your laws, there would be no relativity. In a way, we're both just looking at the same universe from different angles.
Agreed. I suppose we both had our own way of understanding the cosmos. I think I'll stick to my apples for now, Dr. Einstein. But I'll admit your theory has certainly bent my mind.
Well, there you have it. Two geniuses, each with their own way of seeing the universe. What do you think? Who won the debate? Newton with his timeless laws, or Einstein with his mind-bending theory of relativity? Let us know in the comments below.